Wait for my beep. All right. Well, like I said in the last class there, we looked at graphing, just polynomial functions in general. Here we're going to look at graphing. We're going to look at graphing reciprocal functions. So what that means is if you take y equals fx, the reciprocal is just flip it, 1 over f of x. So there's a couple of points here that we're going to use to graph a bunch of different reciprocals. The first one is that the and I'm going to come back to these and refer to them as we're going along, but the x-intercepts of the original function are actually the vertical asymptotes of the reciprocal function. All right, so the x-intercepts, wherever x equals or y equals 0, just like when we had y-intercepts, x equals 0. A reciprocal of a linear and quadratic function has a horizontal asymptote of y equals 0. So that's always going to happen to us because, again, the degree of the denominator will always be higher than the degree of the numerator because, well, you have a number on the top and you're going to have some kind of variable on the bottom. Then this one, intervals of increase on the original function are intervals of decrease on the reciprocal function and vice versa. Because when you flip the function, you flip the up and down. What goes up must come down kind of thing. Now, number 4 here, if the original function has a local min at point x equals a, well, the reciprocal will have a local max at point x equals a, whatever the x value may be. This one, so those ones are pretty straightforward, but this one's a little weird, and we'll get to it. They'll all kind of hopefully make sense when I go through my examples. Is all the y coordinates of a reciprocal function are the reciprocals of the y coordinates of the original functions. Woo! Okay, all the x, y coordinates of the reciprocal function are the reciprocals of the y coordinates of the original function. All right, that's wordy, but we will get to it. All right, so here we go. Again, I'm going to refer to these 5 points. I've got them printed off. I suggest that you had them printed off because I can't keep flipping back because then it'll be just too crazy, but I will refer to them as we do our graphs here. All right, so given the function y equals negative 2x minus 4, which is a nice little linear equation here with a y-intercept of negative 4 and a slope of negative 2, determine the asymptotes, intervals of increase and decrease, max and min of the reciprocal function, and sketch the reciprocal function. All right, so here we go. Try out one of these. So f of x here, our original function, is y equals negative 2x minus 4. All right, now if I was to sketch this graph, which I'll do my best. Like I said, it's got a y-intercept of negative 4 and a negative slope. So it goes down something like this. Again, just a sketch. All right. Now, I'm going to go to my first point. It says the y-intercepts of the original function are the vertical asymptotes of the reciprocal. So over here, I'm going to write down stuff about my reciprocal. My 1 over f of x, or yeah, we'll write it like that. 1 over f of x, the reciprocal. All right. Now, the first thing is the x-intercept. I got to find out where this x-intercept is. And again, that's where it hits that little black dot there. And that is when y is equal to 0. So I'm going to set y equal to 0. So I get 0 is equal to negative 2x minus 4. All right, so I move negative 4 over to the other side. It becomes a positive 4. Divide by 2. Looks like x is equal to negative 2. That would be my x-intercept. Whoops, x-intercept. That means, again, now under my reciprocal, I have a vertical asymptote at x equals negative 2. All right. Now I get to the second point. A reciprocal of a linear and quadratic function has a horizontal asymptote of y equals 0. Well, that's easy. This is a linear equation. I picked a couple easy ones to start out. So we've got a horizontal asymptote at y equals 0. Done. That's second. Intervals of increase. Okay, so intervals of increase of the original functions are intervals of decrease on the reciprocal and vice versa. Well, in this particular function, again, when you're looking for intervals of increase and decrease. You're reading the graph left to right. And this graph does nothing but go down. So interval of, do I have an arrow? No, I don't. All right. Of decrease is negative infinity to infinity. Which means over on my reciprocal here, the opposite is true. Interval of increase goes from infinity. It's the opposite to negative infinity. So our original function is always decreasing. Our reciprocal is always increasing. All right. Let's see. What else do we got here? Y-intercept. That's always key on this graph. We'll get to that, though. Okay, so if the original function has a local min at x equals a, the reciprocal will have a local max. Well, we don't have what's called a min or a max because this thing doesn't curve at all. It just goes straight down. So there's no maximum or minimum. And all the y coordinates of the reciprocal function are the reciprocals of the y coordinates of the original function. So how to explain that is I'm going to come up with a couple of points on my original function. And that's going to allow me to come up with points on my reciprocal. Here's how we're going to do it. All right, so let's see. I'm going to plug in a -1 into my function. I'm going to try one positive number and one negative number. All right, so if I put in a -1 for x, let's see here. -2 times -1 gives me +2. -4 is a -2. All right, that's 1 point. And then I'm going to do another point here of 1. And if I plug in a 1, then I end up getting -6. Okay, so now here's what that means on my original graph. Is that, I messed up. I'll tell you why I messed up. I didn't mess up. But when you are picking points, here's the key. You want 1 point left of your vertical asymptote and 1 point right of your vertical asymptote, so we know where we're going. So I did okay on this one. The -1's not far enough. So I'm going to plug in a -3. That's an important part. -3. All right, so -2 times -3 is a +6 minus 4 is a 2. All right. So let's cross this point. So now on my reciprocal, here's the points, is that your x value stays the same, but your y value is the reciprocal. So when I have an x value of -3, the reciprocal of 2 would be 1/2. That's 1 point. The other point on my reciprocal function is I have an x value of 1, but I take the reciprocal of -6, and I end up with, let's see here, 1 over -6. -1/6. All right. There we go. So now I've got enough information because I went through all my 5 points to graph my reciprocal. Is there any questions so far? All right, so I'm going to draw in my lines here. All right, so my VA at x equals 2. There's my vertical asymptote in red. All right, then we'll put the horizontal asymptote here. Whoops. In green. Y equals 0. That's easy one. Just like this. All right. Now I've got my points. I'm going to plot them. All right. So my points is -3, 1/2. Okay. And then I have 1 way over here. Didn't have to go that far, but I did. -1/6 right in here. Okay. So now here's the key. Is I have to follow, my graph has to go through those points, and yet it has to follow the intervals of increase and decrease. In this case, just increase. So, and it's got to follow my asymptotes. All right. So the only way I can go through this point and constantly be increasing. Now, around it is increasing here, believe it or not. Very small amount, and then woo, a large amount. Following my vertical asymptote and horizontal asymptote, I'm increasing and increasing and increasing and increasing and increasing, going through this point, still increasing, but hugging my asymptote. And there would be the graph of our reciprocal function, a sketch of it. Just following rules of graphing asymptotes. All right, what else do we want to do here? I can't do them all, so I'm going to do 4 and 5. I'm going to do 4 and 5. Let's see here. Given the following graph, determine the asymptotes, intervals of increase and all the stuff we're talking about. All right, and then we sketch the reciprocal function. All right, so I've grabbed a quadratic function here. That's why I wanted to go through this one. And so again, I'm looking at my sheet with my 5 different attributes. All right, and it says the x-intercepts of the original functions are vertical asymptotes of the other. Well, I've got 2 x-intercepts. And so for my reciprocal, I would be looking at the fact that I have a VA at x equals, I don't know, I want to say 2.25, just an estimate there. And I got another one equals negative 2.25. So we got 2 vertical asymptotes. All right. Now, second point, this is definitely a quadratic function. So that means I've got a horizontal asymptote at y equals 0 again. Pretty standard. Okay. Now, next up. Intervals of increase on the original function are intervals of decrease on the reciprocal, and vice versa. Well, you look at this quadratic here, and this quadratic has interval of increase from negative infinity. I don't have a sign for that. We'll write one in, I guess. But then all the way to 0. And then it's 0 at peaks. So that is now telling me, see, right, I'm going to write this all in red. Here, let's go. So we're up here, increasing. Boom, stops increasing from negative infinity to 0. So then that tells me on my graph, my reciprocal, my interval of decrease is that same thing. It's from negative infinity to 0. Now, likewise, that negative infinity in there. Now the intervals of decrease. From 0 on, this graph just goes down. All right, so interval of decrease. Well, that's from 0 to infinity. Flip side of that, that is going to be the interval of increase for our reciprocal. Everything's the opposite. From 0 to infinity. So let's throw some infinities in there. There we go. All right, so we got our intervals of increase and decrease. Fourth one, if it has a max or a min, it's the flip. Well, this graph, because it's a quadratic here, I'm going to wipe that away. We do have a max. It's at 0.5. So I'm going to write that down. Max at 0.5. Well, that means we, on our reciprocal, we have a min at 0.5. Again, because everything's flipped, right? Okay, last one, all y coordinates. Ooh, we got a bunch of VAs here. So I got to find 3 points, actually, because I'll show you when I put my vertical, draw my vertical asymptotes in, which I'm going to do right now in red. So there's one of them. Again, just a sketch. I'm on a mouse here with tendonitis in my hand. There's the other one. So there's our two VAs. All right, well, if I pick one in the middle here, it's going to be, left of one and right of the other. So it's in the middle, and so I got to find 1 point left of my VA and 1 point right of my VA. So first point I'm going to do is the 0 point. All right, so we'll do points. Let's see. So I go 0, and, well, the y-intercept is 5. All right, so there's 1 point. Then I got to go left of my graph here. What about -4 here? -4. I'll try an x value of -4. And it looks like it's way down here. -10. All the way down. -4, -10. Flip side, I can also do x equals 4. And, well, because it's a quadratic, the y value is also -10. Now, what does that mean for my reciprocal? Because that's a final information I need. All right, so my points then would be, on my reciprocal, we're going to be, well, 0, then 1/5, because you're taking the reciprocal of the y-coordinate. Then we got -4, -1/10, very small number, 0.1. And then the last point that we're going to use is 4, -1/10. All right, there we go. So there's all our info that we have. Just checking the chat here, make sure there's no questions. It's not the easiest stuff. Okay, so now I'm going to plot my points and use all my information because I've already got, well, actually, I should put in my horizontal asymptote here. Here we go, green line. I got my verticals in red. All right, now I'm going to do my points. I might as well pick blue here. So 0, 1/5. All right. It says I have a min. Here's something I messed up. The min should be at 0, 1/5 because I forgot to take the reciprocal of the y-coordinate. So there's actually my min right there. Killed two birds with one stone there. I got a point in between my VAs, and I also got a min, or a max, or sorry, a min. A min. All right, so that's a min point there, that blue. Then I've got -4, 1/10. -1/10. So -1, 2, 3, 4, down 1/10, right in there. Same thing over here, 4, 1/10, -1/10. There we go. So I got my 3 points in there. Now I'm going to sketch it in using my information. I'm going to start left to right here. Interval of decrease. So I know for this first blue point that moving left to right, the graph constantly has to be decreasing, and I've got to follow my asymptotes. There we go. You can't see it by my pen there, but it is decreasing, very small amount, and then it's, as it gets to the vertical asymptote, dives down. Now, interval of decrease, it still continues on. I'm going to go through my blue dot here, following my asymptotes. It goes down, still decreasing, and then it hits. And that's where I have a minimum. Just put an arrow here. Then we have an interval of increasing from there on in. So after this dot, it goes up. And then finally, my third blue dot, again, I'm on an interval of increase following my asymptotes. So I'm moving up, moving up, moving up, following my asymptotes, and still moving up. You just can't tell. And there we go. There's what our graph looks like. Funky looking graph. All right. Can do one more here. For the function f of x, another quadratic here, but in standard form, equals x squared minus 2x minus 8. Sketch f of x first off, and its reciprocal. Okay. So I'm going to sketch this thing first. Oh, it's all one piece. All right. Okay. So first off, I got to sketch this. So I need to find my x-intercepts. That's key. So what I'm going to do is factor it. All right, a little bit of factoring. I don't want to run a room here, but we'll do a little factoring, I guess, over here. All right, so if I factoring this thing, I have an x squared on the top, -8 on the bottom. Hopefully you remember this stuff. We did a bunch of it. X and X always. I need two things that multiply to give me -8. But yeah, then when I do this cross multiplying, I'm going to get -2. I'm going to go with -4 and 2. And cross multiply here, 2x minus 4x. Yep, that gives me the right middle number of -2x. All right, so now I know that f of x, factored anyways, is equal to, what do I got up there? X minus 4 and times x plus 2. All right, so those, that's my, why am I doing that? Why am I factoring my quadratic here? Well, because I want to find the x-intercepts, which are simply when our function becomes 0 or y equals 0. So my x-intercepts, well, I'm going to first bracket there, x equals 4, I plug in a 4, and I also have x equals -2. Those are my two x-intercepts, so I can plot them on my original function here. Let's see here, -2, there's 1, and 4. There we go. All right, now to find the vertex, right? I want to find the top point. The vertex is always in the middle because, again, a quadratic is symmetric. So what's the x value in the middle of -2 and 4 here? 2 this way, 2 that way. I can add them up and divide by 2. So let's see, add them up. Let's see, vertex is at x equals 4 plus -2 is -2 divided by 2. That's the average. -1. Okay. Now to sub in f of -1, because I actually want to find out where that vertex is. All right, I got -1 minus 4. I'm subbing into the factored, whoops, -1 minus 4 times -1 plus 2. And so let's see here. I get -5 times 1. So it's just -5. All right. Let's see here. I'm going too fast here. -1 times -5, -1 plus 2. Yeah, -5. Believe that's right. All right. So I'm going to plot my other dot. Let's see here. We're going to fit it on there. 1, 2, 3, 4, 5. Yeah, I can. Beautiful. All right. So there is a sketch of my quadratic here. Just making sure I get that right number. Yep, -5. Okay. All right. Now I'm going to sketch its reciprocal. We've got the original function in there, and we got the ability. I guess I should get some points too. Oh, well, let's see. Yeah, I probably need a point or two, don't we? Well, first of all, we'll get to that. First off, x-intercepts of x equals 4 and x equals -2. So that, again, is telling me on my reciprocal, wish I had a bigger page here, that my VA is at those same things, x equals 4 and x equals -2. All right, now, clearly this is a quadratic, so my horizontal asymptote, once again, is at y equals 0. All right, intervals of increase and decrease. First off, I didn't plot this right here. Hold on, folks. I messed something. I knew I messed something up here. I'm going back here. Hold on. Get my y-intercepts in here. Figured to mess something up here. It's not a -1. I went too fast. See what happens when you go too fast? It's 1. 4 plus -2 is 2. Divided by 2 is 1. So that should be a 1. And that should be a 1. And so now I've got -3 times 3. -9. All right. Oh, sorry about that. Again, feel free to correct me, folks. I don't have the answers in front of me, so sometimes I don't have the answers. All right, so I still got my x-intercepts here. 1, now I can't go down to -9. It's down here somewhere. 1, -9, down here. All right, there's a sketch of my function. Again, that point is 1, -9. That's my vertex. All right. So again, that means my x-intercept is at, oh, no, that's still right. Okay, that's good. All right, so now going through my other parts. Again, I got my sheet out, found my x-intercepts, found my VAs because of that. It's a quadratic function. So again, my horizontal asymptote is y equals 0. Intervals of increase and decrease. All right, so this one, instead of going back and forth here, our original function is decreasing all the way to x equals 1. So that means that our reciprocal is going to be increasing. Or interval of increase, excuse me, is from negative infinity, which I'm going to, negative infinity, 1. And also with the original function, now it increases from 1 onwards. So on our reciprocal, that's our interval of decrease. It's from 1 to infinity. I'll throw in there. So let's put some infinities in there. There we go. All right, and the last part is here, a minimum. So this graph here, mins and maxes, has a minimum at 1, -9. It has a minimum. That means our reciprocal will have a max at 1. Now, this is the part I messed up before. You got to take the reciprocal of the point, so it'd be -1/9. Flip it. Everything's flipped. So our original function has a max at 1, -9. Or a minute 1, -9. So our reciprocal has a max at 1, -1/9. All right. Now points. We need points to plot here on our graph. So you need something right of our vertical asymptotes and left of our vertical asymptotes, because this one is in the middle of -4 and -2 and 4. So we're good. We got 1 point there, our max here. Let's see, points. Well, I don't know points. I'm going to have to use my function here. So let's see here to get a couple points. I got to go left of -2, I guess. I got to go left of. So let's see here. I got to try -3. And I'm not sure why the font changed all of a sudden, but let's see. I plug in a -3 into my function here so I can see it. Here we go. -3 in there. -3 minus 4 is -7 times a -1. -3. I don't want to mess this up again. Whoops. -3, plug it in. -7 times a -1 is 7. -3, 7 is a point. Okay. I need a number right of our vertical asymptote of 4. So let's try 5, I guess, because we got 1 in the middle again. That's our max point there. So let's go with 5. 5 minus 4 is 1. And again, it would be 7. Make sure you're right. Okay. So that means those are points on our original graph. So points on our reciprocal then. Fonts drive me nuts. All right, points on our reciprocal would be -3, 1/7. And then the other point we could use is 5, 1/7. All right, there we go. We're ready. A lot of work. Wait till you get to calculus, so a lot more work. Graph these things in detail. That's why ours are just sketches. So I'm going to put in my VAs here. X equals 4. There's one of them. X equals -2. There's the other. My horizontal asymptote. There we go. All right, now to graph this thing. Let's get rid of this stuff. We don't need that anymore. All right, so now to graph it. Points. We have a max at 1, -9. So move over 1, -1/9. Again, it's just a sketch somewhere in there. I have other points here. -3, 1/7. Okay, right in there. And then I've got 5 1/7. Okay, there we go. So just having those points there is telling us on what sides of those asymptotes we're looking at. Now, in terms of our interval of increase and decrease, it says we're always increasing from -infinity to 1. So -infinity, I'm increasing, I'm increasing, I'm increasing. Up I go, really increasing. Then I get to my asymptote. Then I keep increasing, but I'm starting down low here. And I go to my point, which is at 1. Then I stop increasing. But guess what? It's a max here. That's why, because then it starts turning down. And we end up with our interval of decreasing. Down we go. All right, now it says we're still decreasing. So I have to start up here because I'm going through my other blue point here. And I keep decreasing as I hug my asymptote. And there we go. There's what our graph ends up looking like. Just following the reciprocal, graphing the reciprocal there, which was a quadratic that we had to factor.